Microbium is a fun and friendly sandbox for experimentation with simulation-based generative art. Designed for simplicity, you will only need to learn one brush tool to start making interesting art. In-depth style and motion can be achieved with the flexible rendering and simulating systems. To get started, download the built application or clone the GitHub repo and build from the source. Once the app is running, get acquainted with the UI control interface. This is where you manipulate the parameters that will control the brush tool, view and camera settings, simulation forces and constraint groups, line and fill style layers, generative geometry modifiers, and finally, post-processing effects. The default scene includes a basic setup of a few active physics forces, physics constraint types, and line style layers. Each new drawn line will be linked to the active physics constraint type and style layer. Updating the properties of a constraint group or style layer will update all linked lines. Properties can be updated in the control panel or bound to MIDI CC channels. When bound to a CC channel, each controller can also record inputs over time and play them back in a looping sequence. This integration allows live, complex modulation of many parameters. When navigating the editor viewport, hold Option and click and drag to pan the camera view. Draw strokes by clicking to precisely add each point individually, or click and drag to draw a fluid path. Each path can become interconnected to other paths by clicking on top of an existing point, creating a shared vertex. Closed paths are rendered with a 2D fill. The scene visualizer runs in two modes, editing and simulating. When running a simulation, new paths cannot be added, but cursor movement can be mapped to active forces to influence the simulation. When switching back into editing mode, all mutations to the geometry are preserved and new paths can be added. Geometry modifiers and post-processing effects are a big part of the rendering engine. Polar duplication, color correction filters, and blurred feedback are a few effects that can be tuned for each scene's look. Microbium was built using web technologies and packaged with Electron for distribution. It's comprised of two main pieces, the visualizer engine and the UI control interface. The controller UI is composed of modular components built with the Vue.js framework, and the visualizer is rendered with a custom engine using a WebGL backend. The main visualizer view is built with WebGL library Regal, which is described as a functional, data-driven abstraction layer on top of the native WebGL API. The library exposes two primary interfaces, commands and GPU resources. A command is a complete representation of the WebGL state required to perform some draw call. A resource is a handle to a GPU resident object like a texture, FBO, or buffer. This is really a useful library to get started with WebGL and shaders, as it greatly simplifies the complex state management needed to set up shader programs and resources, while still providing low-level access to all the features of the native WebGL API. As WebGL has poor native support for line rendering, the app uses a custom-built line rendering library. Each subsection of a line or curve is drawn as a screen-projected quad with projection computation running on the GPU in a vertex shader. Rendering lines this way enables smooth tapering of line weights, as well as use of fragment shader modulation and texture sampling to render complex stroke patterns and shapes. The fluid-like kinetic animation characteristics of scenes rendered in this app are driven by a custom lightweight physics engine. Each vertex in the vector network becomes a particle in the simulation, while each subsection of a line segment becomes a distant constraint. Global forces act on particles while constraints maintain local relationships. All particle vertices are stored in a single typed array which is mutated by all active constraints and forces. This architecture is really fast and memory efficient even for large simulations. The system is based on the one used in the first Hitman game, known for its ragdoll character physics. Drawn vectors in a scene are created with a vector network architecture. Unlike most vector-based systems which compose individual isolated paths, all paths in this network can become connected and merged into any other path. This allows complex structures and shapes to be built up out of interconnected paths and lines. For each frame, the full state of the current scene and controller parameters is pushed through a set of Regal draw commands. This style of building commands in Regal was inspired by React and ensures that the rendered scene is always up to date with the current scene state. This style is much different from an object-oriented design such as Three.js, which manages discrete objects in a graph. For instance, to draw 8 radial iterations of a line, the draw command is run 8 times according to the underlying data. In contrast, Three.js would require managing the addition and removal of unique objects from the scene. Scene state is serialized in multiple steps. Repetitive keys are remapped to abbreviated names, typed arrays are converted to compact string representations, then everything is stringified to JSON and saved to disk as a gzip text file. This process is reversed for loading a scene and generally takes 1 to 2 milliseconds, allowing hot swapping scenes while a simulation is running. Microbium is an open source project hosted on GitHub under the Microbium organization. I hope you feel encouraged to check it out and tinker with the code or start a similar generative art project of your own.